I am Rajesh Uppal, Director IDST. We bring sharp insights and foresight on defense, security, and emerging tech. Let's dive in.
Imagine trying to move tanks, troops, fuel, and medical supplies across thousands of miles of open ocean with no runways, no ports, and enemy sensors watching every move. For decades, that problem has haunted military planners, and for decades, it had no real solution. Until now. Today, DARPA is attempting something that sounds like science fiction, a giant aircraft that doesn't need runways, that lands on open ocean, that skims the sea like a ghost, and that could completely reshape how wars, disasters, and logistics unfold across the Indo-Pacific. They call it Liberty Lifter, and it may become the most disruptive logistics aircraft built since the jet age. Long before Liberty Lifter, the dream already existed. During the Cold War, the Soviet Union built strange hybrid vehicles called ekranoplans. They flew just above the water using a phenomenon called ground effect, where air gets trapped between the wing and the surface, creating extra lift and lower drag. The biggest of them, the Lun class, carried missiles and skimmed the Caspian Sea at jet-like speeds. But there was a problem. They were unstable, hard to control, and nearly useless in rough weather. Once the seas got violent, the dream collapsed. For decades, the idea was abandoned, until DARPA decided to resurrect it and fundamentally rewrite it. To understand why Liberty Lifter matters, first understand amphibious aircraft. These are aircraft that can take off and land on both land and water. They are heavier and more complex than normal airplanes, but they don't rely on airfields. Compared to helicopters, they are dramatically faster and far more efficient at long distances. That's why amphibious aircraft have long been used for ocean rescues, island supply, and disaster relief. Liberty Lifter takes that basic idea and scales it to strategic military dimensions, not rescue scale, war scale logistics. DARPA launched the Liberty Lifter program in 2022 with the radical goal: build a runway-independent heavy transport aircraft that combines the payload of ships with the speed of airplanes and the freedom of the open sea. Ships are slow and port-dependent. Airplanes are fast but chained to runways. Helicopters are flexible but short-ranged and payload-limited. Liberty Lifter is designed to erase all three limitations at once. It will take off from water, fly across oceans, and land on nothing but waves. But engineering that is not just hard, it's brutal. The aircraft must survive violent seas, massive structural loads, and complex airflow where ocean and sky collide. DARPA engineers focused on three historic roadblocks: rough water, manufacturing cost, and control at the air-sea boundary. On the water side, Liberty Lifter is being designed to operate in Sea State 5. That means waves over 13 feet high. For context, most seaplanes operate safely only up to 4 feet. This aircraft must punch through chaos. Its hull is tested in massive hydrodynamic labs that simulate storm-driven ocean forces. Every impact, every shock, every wave slam is modeled. On the manufacturing side, DARPA took a shocking approach. They abandoned traditional aerospace manufacturing. Instead of ultra-expensive aerospace composites, Liberty Lifter will be built using shipyard-style construction, the same industrial logic used to build cargo ships. Why? Because Liberty Lifter isn't meant to be a boutique prototype. It's meant to be mass-produced. Finally, the hardest problem of all, the moment where water becomes air. During takeoff and landing, Liberty Lifter must survive aerodynamic forces and hydrodynamic forces at the same time, something no conventional aircraft ever experiences. To manage that chaos, the aircraft will rely on advanced sensors and adaptive flight computers that constantly reshape how the control surfaces respond to waves, wind, and air pressure in real time. This is not simple flight. This is controlled chaos. In Phase 1, DARPA funded two rival designs. General Atomics pursued a twin-hull catamaran-style aircraft, extremely stable, built using commercial shipyard logic, designed to land heavy vehicles directly via front and rear cargo ramps. Their concept could carry two Marine Corps amphibious combat vehicles, operate autonomously at sea for weeks, and dynamically react to turbulent wave forces using advanced computing. At the same time, Aurora Flight Sciences, a Boeing subsidiary, pursued a very different path. A single-hull flying boat design, more traditional in shape, more optimized for higher altitude aerodynamic efficiency. DARPA ultimately selected Aurora to move forward, not because General Atomics failed, but because Aurora's design offered faster near-term scalability towards full production. Now in Phase 2, Aurora's vision is becoming real metal. The demonstrator will feature a massive 216-foot wingspan, 8 turboprop engines for redundancy and power, wingtip floats for ocean stability, and a massive rear cargo ramp for direct beach deployment. The scaled prototype will carry 25 tons of cargo, equal to a C-130. The full production version could carry up to 82 tons, in the same class as the C-17 Globemaster. But the most extraordinary feature remains how it flies. Liberty Lifter can skim the wave tops in ground effect mode for fuel efficiency and stealth, then climb to 10,000 feet to avoid storms, mountains, or detection. No previous seaplane in history has combined both abilities at this scale. And now the real strategic reason this matters: the Indo-Pacific. Thousands of islands, few runways, few deep water ports, vast distances, and rising geopolitical tension. Traditional logistics systems were designed for Europe with dense infrastructure. They break down across the Pacific. Liberty Lifter thrives exactly where modern logistics fails. It moves 3 times faster than ships. It carries triple the payload of a C-130. It operates without airfields or ports, and at low altitude, it is extremely difficult to detect on radar. This enables something militaries desperately want: distributed operations. Small forces, spread across islands, supplied from the sea. Hard to target, hard to strangle. Liberty Lifter becomes the invisible artery of future Pacific warfare. The development timeline is aggressive. 2024-2025, component testing, wind tunnels, pilot simulators. 2026, critical design review and shipyard construction. 2028-2029, water-only flight testing, no runways at all. Early 2030s, potential operational service. If it succeeds, this aircraft won't belong to a base. It will belong to the ocean itself. But Liberty Lifter is not just a weapon of war. Its civilian potential is enormous. Imagine hurricanes wiping out entire coastlines, with ports destroyed and airfields flooded. Liberty Lifter could land directly offshore and deliver mobile hospitals, generators, food, water, and evacuation capacity for hundreds of people at once. Search and rescue missions that once took weeks could take hours. Humanitarian logistics that once depended on ports could flow straight from the sea. At its core, Liberty Lifter represents something deeper. It represents a merger of two domains humanity has always treated separately: ships and airplanes, sea and sky. And for the first time, that boundary is dissolving at strategic scale. As Aurora's leadership put it, this isn't just an aircraft, it's a new category of vehicle. And that may be the truest statement of all. If Liberty Lifter succeeds, the future of military power will no longer depend on runways or ports. It will depend on the open ocean. Force will move where geography once blocked it. Supply will flow where infrastructure never existed. And logistics, the silent backbone of all warfare, will finally break free from land. The age of runway-bound power is ending. The age of floating air power is about to begin.
Thanks for watching. Subscribe, follow, or visit idsth.com for more cutting-edge defense and tech insights. See you in the next one.